Okay, so we were going to try to do this problem on the on one of our video conferences, but we've been having all sorts of network issues. So I'm going ahead and solving it and posting it out there. Okay, so this is actually going to end up being a fairly simple proof, because what we need to do essentially is open up all the appropriate definitions. So the first thing that we need to do is we need to rewrite that as for all x belongs to the intersection of s and t. That implies that x belongs to the union of s and t. Okay, and what that is just the definition of subset. Okay, and if you look back at the slides or at the video on defining subset, that's what it said, right? A subset B is the same thing as saying for all x belongs to A implies that x belongs to B. So that's what we have here. Okay, now next step that we'll do is just like any of the proofs that we have, we're going to get rid of quantifiers. Okay, so that's just removing for all x. Okay, and I could name it to x sub 0 or x sub 1, but there's no need. You know, I mean, I just know that x now is untouchable. It is a constant term. Okay, all right. So next step is this is a predicate, and I can actually open up the definition, because x belongs to oh, rather let me just focus on the part that I want to use. S intersect t is a set, and I can just open up the definition of that. So this means that x belongs to the set of all x such that x belongs to s and x belongs to t. Okay, and I'll do the same thing for this other term. So this should imply that x belongs to the set of all x such that x belongs to s or x belongs to t. Okay, and the reason that I can do that is just the definition of intersection and union. Okay, and again, you can go back to those videos, you can look at the slides for those days, and you'll see that that's what we said when we said what exactly is the set of S union T? Oh, that's the set of all x such that x belongs to S or x belongs to T. So now all we got to do is that stuff that says, oh, how do I go from belongs to you know, to predicates, to logic. And the way that we do that is, oh, this is a set defined by a property, so that means that x must have that property. So I can say that means that x belongs to S and x belongs to T, because that's the property, right? That should imply that x belongs to S or x belongs to T.
Hello.
And because I have different you know, ands and ors as well as implies, I'm going to put parentheses to make sure that this is you know, well defined. Okay, so we have that term, and like I said, that's just from essentially from definition of belongs to, right? At least belonging to a set defined by a property. All right, now here x belongs to S. Remember that that's actually a predicate. Okay, I could write that as belongs to x comma S, right, if I wanted to. This is a predicate, right? This is a predicate. That is a predicate. All of these things are predicate. And x, s, t are all constants. Okay, so our predicates are really propositions, right? I mean, when you see x belongs to S, that's either true or false. X belongs to T, that's either true or false, right? And things that are either true or false, we call propositions. Now, the reason that I mentioned that is because then I can say that this term here, I should put some equals here, this term here is actually equal to just true. Okay, and the reason it is by propositional reasoning. Okay, and if you want to see the propositional reasoning that's going on here, it's just basically A and B implies A or B. Okay, and this is the kind of thing that I would ask you to prove in the section on propositional reasoning, right? But it's not the kind of thing that I would ask you to prove at this point in an exam, because I expect you to have already known that, and you already have demonstrated to me in a prior problem that you know that. So now it's just a matter of making sure that you know how to manipulate sets, right? That's what this problem would be about. Okay, I hope that clears up that problem. And sorry about all the technical issues. I do not know what's going on with the network.